And ready, set, go. Hi, everybody. My name is Urban Reininger. I'm a computer science teacher at East Hampton High School, and this one is really for my students. We've been doing I've been teaching a Python class. This one has to do with how to kind of make a basic calculator that can do addition, subtraction, multiplication, and division. And it's using user input. It has some while loops in it. It's a kind of a good all-around one. It's not super exciting, like gamey, graphic-y stuff, but it does teach you a lot of kind of the basics of how to use user input and how to kind of handle that stuff in functions. So without any further ado, I'm going to go ahead and create it. I'm using a program here called Trinket, and it's a website, I should say, more than a program, but it's running a virtual version of Python in there, and we can do all of the stuff we need to do for this in here. So we're running about maybe, I don't know, 30 lines of code tops, I think. Maybe more if you want to add a little bit to it. But let's start off here and go ahead and create a new one in here. So we're going to go up to the top here. We're going to make a new Trinket. It just needs to be standard Python. It doesn't need to be Python 3, although the code we're writing should work in Python 3 too. So you can go either way with it. This computer trying to capture is a little bit slow today, but let's see how we're doing. I don't really have the ideal setup here for Mr. YouTube-y kind of Mr. Coding stuff, but here we go. So I'm going to give this really quick a name. Just name and save it right away. We'll call it the calcinator. If you happen to know what I'm talking about, inator, maybe mention it down in the comments. And remember, when you're doing Python, if you have a hashtag or that number sign at the beginning, then that's going to be a comment. So we want to use that. I'm going to say basic calculator program. And just the year that we're doing this. I usually add in there too, fall 2020. And so what do we want to do at the very beginning here is we're just going to welcome the user. We're going to kind of put in user interface pieces as we go. We're going to say, go ahead and print, welcome to the calcinator. And if we want to put a new line to maybe give it a little bit of space, we can do that with a simple /n. Anytime you see that /n, and that's the slash that's above like the enter or return key, that'll make it so it goes on to the next line. That kind of gives you a little extra space when you write stuff. Next, what we're going to do is we're going to try to ask the user for maybe some input, and then we'll use that input to do a basic kind of addition thing, and then we'll build the rest of the program up from there. So to start off with, we'll say, let's pick like a num1, and we'll have a num2, so we can have two numbers that are coming in. We'll make num1 a variable, and we'll ask the user for input. So we'll say input something like, I don't know, enter your first number. We'll talk about what we're going to use for it. And we'll do one for the enter your second number. And then we'll talk about the errors that we might get here along the way. We're going to say enter your second number. So if I were to run that one right now, I'm going to hit save first, of course. And share apparently. Don't do that. Hit save. If I go ahead and click the play run button that's over here on the side, and somehow get rid of my there, it says welcome to the calculator. Enter your first number. So here I'm going to enter 2, here I enter 3. Yeah, I entered some numbers. It didn't do a diggity darn thing with them, but we did enter a couple numbers here. And so let's go on to the next step where we can kind of have it do something with those. And I could have it very quickly just kind of print out, I don't know, whatever the result is. We'll call it result is going to equal num1 plus num2. So we're essentially making something that can print out these two things. I'm going to use parentheses. Python 3 uses parentheses. Python 2 doesn't. So here's probably going to be our first error. If I try to run this one right now, and I put in my two numbers, 2 and oops. Make sure you click on this side of the screen like the area where it's running the program, before you try to enter values. If you don't do that, then it'll end up typing in your code side, and on that side, on the far side, oh, my hand. But if you go on that side, on the side I'm on, you'll be fine. But if I put in those two and I try to have it run it, I get this result. So this result right here is showing that it's 2, 3. Now 2 plus 3 is not equal to that unless you're treating those like characters or like strings. Anytime you input, and this is a really important idea, anytime you're giving user input into the machine in Python, it's gonna treat it like a string. So I could put in anything I wanted in here. Let me run the program again and show you. For my first number, I click on this side, I type in 200, and I could say from there, chickens. And so now it's just taking those two things and it's putting those things together. Now I've got 200 chicken is my new phrase there. And that's because it's just treating both of those like words and putting them together. It's not doing any kind of math with them. In order for Python to treat anything like that, it needs to know it's a number. It needs to be converted to a number. So we get out like our magic wand and we're going to magically change it into being a number. And to do that, the term is called casting. So we're going to cast these numbers, the num1 and num2, to make sure they're integers, or which is any whole number, or I mean, most calculators, you're not usually just putting integers in, right? So we might want them to be a float, meaning they have a floating point going around. That floating point, maybe you know as a decimal. So we're going to use that. And to do that, we can do two things. We can either we can do one of two things. We can either right now in my code, I could say make this be a float here and convert it each time I do it. Or what I can do is I can say, instead, I can say right when I first get it, make it a float. So I can take whatever that input is that I got there on line 6, and I can say float everything that I just took as the input. Woo-ah. So I can do that. Now if I want to do it on the next one, that would make good sense too. And I do those two, and now if I try to do the same thing again, let me run it. Now if I put in a 2 and I put in my 3, you'll now see the result is 5.0. You'll notice that there's a 0.0 there. Because I said they're going to be floats, it's going to assume that all the numbers are coming in are floats. If I were to print out, and you don't need to type this, but if I were to print out num1 after I've collected it, and print out num2 after I've collected it, because I'm casting and then I'm magically like turning it into being a floating point being a decimal, when I run this and I type in my numbers, whether it be 30 and 20 or 2 and 3, you can see the numbers that it's printing out is going to have that decimal in there. It's going to treat it, actually convert it into being a float. And we know that now that is definitely a float because of the decimal 0, even though we didn't add any other digits past that. So we don't really need these two, the num1 and num2 right now. But let's do a couple other bits here. So here we have one where it does this. Now it's really just the addinator. It's not really calculating any operation we want. So we probably want to now ask it, like have it ask the user, what operation do you want to have it do? So let's make that be a question right after welcome to the calculator. Let's have it maybe do the next step, and we'll say what should we do for it? Let's have it pick maybe some sort of operation. Or maybe we just call it operation. Let's call it operation. Operation. And then here we can have this be another input. We don't need to cast this to a number because we don't want it to do that in this case. We're going to say, what operation do you want to perform? Question mark, and then we can say like addition, subtraction, multiplication, comma, division. And maybe it would be better if we put these all on a new line themselves. So I'll do a /n here and say addition, subtraction. And this is going to scroll off my screen, and you'll be like, no. Actually, maybe I should put it on, put it in its own line. Let's put it in its own line. We'll put it down here. How can we write this better? What operation do you want to perform? Usually I would do this all in one line, but only because I'm doing this as and trying to keep it all on this window. Am I going to keep it? Am I not going to do that? So I'm going to say, what operation do you want to perform? And then I'm going to say, in the input part, and what the question I'm going to ask for my input, addition, subtraction, Whoa. Somebody's going to catch a mistake and have to write it in the chat, but I'm trying to be quick here. Division. ASMD. That's what I want them to type in. I want them to type in one of those letters instead of, all right, so that looks fine. Or I guess I need one more of that. There we go. Let me save that and just make sure it works. And I'll do my run, hit the play button. And what did I miss? Oh, quotes here. I'm missing a closing set of quotes. Quotes. Question mark quotes. Save. Let's see what that looks like. I feel like the spacing here is going to be a little wacky because I had to stretch it all out. You can pause it here in the video if you want. What operations do you want to perform? ASMD. And now we can have them put in some sort of value. Here, if I put in A, it should just kind of be, okay, hey, you gave me an A, great. Let's try hitting play one more time. Here it's asking the question. I say A. It's asking me for numbers, 3 and 2. And here it's just still doing the adding. We want to actually make it have, change its operation based on what value I put in there, or what letter I put in there. So this is where I need to come down and really be kind of smart about how I set this up. So let me go down a little bit. I'm going to say if operation equals A, then I can tell it to actually print out this result. Now, remember when you're doing an if statement, you're going to use that colon, and then after the colon, you're going to tab in anything that you want to happen when that if statement is true. So inside that if statement, we're going to say operation equal A. When that is true, then you do the two things or whatever number of things that are tabbed in or spaced in, indentations, indented, there we go, intended below that. So it's getting late in the day, and forgive me, but we'll see if we can do this. So if we do this one, now it should actually run those other ones for us. And if I don't choose those, if I pick an S and I put in my numbers, it shouldn't do anything. But if I run the program again, and now I add in an A, it'll ask me my numbers, put those together, and it is giving me the result of 5. So you could pause here for a minute and try to test it, see if yours will do the same thing. It should only do that operation when you type in the A for it. So this is kind of one of those little quick parts here. I can see I'm like super blurry at the moment. Let's see, I wonder how long I've been blurry for. Not gonna stop, we're gonna keep going. So what we want to be able to do here is we want to make it so that we can do this multiple times. Plus, we also want to make sure that somebody doesn't put garbage input into this. But I can take all of these number, like I can do this one for addition and multiplication and other ones. I can really simplify this in a way and have it do all kinds of other functions if I just know like what I want that to do. So I can make an actual function out of this instead. So instead I could maybe take these 2 lines I have already and say def, let's call this the adder, and we'll have it take in num1, comma num2. Or we can even just be it like num1, n1, n2 at this point. I don't know if that simplifies it or makes it more confusing. And if I were to run this same one, instead of it doing this as the operation, I can ask it to run the adder and send to the adder num1, num2. This is going to be super confusing for any of you that are just kind of randomly jumping into this. Let me put this function before. So now as it plays down the program, it's going to go very linearly. I need to have that adding function that we see right here. I need that to happen before I try to call it. So down here, when the if statement comes up and asks if the operation is valid, I can now say, hey, it's A. Now let's send those values to the adder function and have it do it from there. Yay! So let's add in a couple other ones here. Here we've got an adder function. Let's add in the other functions really quickly. We're going to say, just say subtract n1, n2, colon. Oh, I didn't do that one right, did I? Go back, take that extra comma out. That's garbage. There we go. All right, result is going to equal n1 plus n2. Oh no, subtraction n2, and then print result. And we really could actually be doing this. I'm making this a little bit more complicated right now for a long-term reason. But if we wanted to, we could just make each of these if statements. We could do it all within this little statement here. We could say just print n1 minus n2 and have it done right there. But we're trying to incorporate functions here, but keep it simple. So here is my multiplication. Multiply n1, n2, and result n equals n1 asterisk, remember shift 8, n2, and the print our result. Yep. And lastly, def subtract. Oh no, so to divide, sorry, divide. It is getting late. And colon, so because we're defining a function. So imagine, like, it's very godlike when you get to define the word divide now does this, and the word multiply does this. So you're inventing words and commands here with creating functions. It's a very kind of powerful thing when you are confidently making functions. And so we're going to say the result here of n1 divided by, using the slash this time, n2. And let's have it print result. Now there's other ways we could do this where we maybe return it or do things like that. And we'll pretty up our results here later on when we get a little bit further on. But right now, let's see how we're doing with this one. We're going to test this out just a little bit. I'm going to also now add in a couple other bits here. And because this is kind of a recap, I'm sorry if you happen to be somebody, operation, we're going to say equal s, and we're going to say, what did I say, subtract num1 comma num2, 2. So now it should be sending to the function these two numbers. It should send the number 1 and number 2 that we've already collected up on lines 9 and 10. And we're going to tell it to, hey, send that to that subtract function and print out and do your thing with it. So here's what we're going to do. Let's run this one and see if it works with the subtract, see what mistakes I've come up with. I click over here, I hit S, I'm going to say 5 minus 2, and we get 3. So it's amazingly I didn't have an error. Hey, first time for everything, right? So what do we got next? So there we've got our addition, that, subtraction, it all is looking pretty good. I could very easily pretty this up just a little bit, and the example that I would maybe give here is, I could say, when you print it out, you could say, n1 plus, we need to do this tricky thing where we say str n1, because in In Python, we need to cast it back to a string in order to print it with other letters. We can print out numbers just fine if we just print them by themselves. We can print out floats, and we can print out integers and other stuff just by itself. But if we want to combine them with other words to make them pretty and make sense in a sentence, then we have to convert numbers back into a string. So the magical casting one comes out again, and we cast it to be a string, which just means str before you print it out. So we're going to say str plus, and I'll show you what this ends up looking like. str plus str. No. I want to put some letters in here, right? Subtract. So I can say minus plus str. It's probably better off I just do it first and then explain. And 2 plus equals plus result, which is now got to be str'd as well. We're almost there. Bam! All right, so what did I do here? I'm printing out the number, num1, or n1 in this case, and then I'm adding to that, like I'm making this string, all this one long piece of stringiness, and I'm going to say print out the minus sign, and then print out the number, and then print out the equal sign, and then print out the result. So assuming I did any of that right, let's hit the play button here and see what goes. Here I type in S. I'm going to try a number, 5, just a number, and a 3, and there we are. So it says 5.0 minus 3 is equal to 2, and it's kind of much more readable. It just doesn't give you just the readout of the other piece as we go. Now, if you're having problems at this point and you're typing in S or A and it doesn't seem to be working, it could be that you're typing in that S. That S right there. Do you see that S? That S right there is not a particularly great S to be doing because that one's a small s. And it doesn't like that. It doesn't want to see a small s. It wants to see a capital S because, frankly, down here on line 31, that's why I said it should be a capital S. So there is an easy way to kind of solve this rather than doing like a whole nother if statement and trying to say, hey, we need to know when it's a big S and a little s, and yeah, we don't want to do multiple if statements. But there is a way to tell it to take whatever input the user gives and capitalize it. So let's do that for each of these just so we're clear that it's a good thing. So we're going to say uppercase, I think it's upper or uppercase, I think. Do I have notes for this? Upper. It's just upper. So if I say operation uppercase, operation dot uppercase, or just upper, sorry, just upper, just a little, there we go. All right, so now if I type in a lowercase a and I type in numbers, it's happy and it works. And if I type in a lowercase s over here and I run it, it should end up having the same thing. And here we've got a beautiful output on that one, which I haven't done on the addition one yet. But we're really moving along here. Now we can do addition, subtraction. We have a couple of them with some pretty output. Quickly here, we can kind of throw in the next two. It shouldn't be more than just a moment or two. And let me take, I'm going to copy this. I'm going to be a lazy coder because most coders are pretty lazy and try to use code whenever possible. So we're going to say M for multiplication, multiply. I don't know why I'm having trouble with that today. Divide, yeah, and we need that to be a D. So now I should be able to do addition, subtraction, multiplication, and division. Whew, okay. So far, this program can kind of do those basic things. And it has a little bit of a correction here where I can type in letters that are maybe too big. I'm going to hit save before I do something stupid. And let me hit play again. And let me do multiplication. 4 and 5 maybe. Yeah, that looks right. And I do it one more time here. And I click and type in D. And now I can be like 3 and 4. Oh, look at that. That's 3/4 is 0.75. Rocking. All right, we're totally killing this so far. We're doing great with it. Now, there's kind of a little catch here. What if I start putting in things that don't work? Or if I'm doing a lot of this, if I'm doing a whole lot of this, I probably don't want to always have to go back to that play button every time, especially if we're in something that isn't maybe Trinket, that has a nice, easily placed play button for all of it. We may want to have it keep asking me, hey, you know what? Do you want to do again? I can say yes, I want to do it again, or I can say no, I'm done, and then it could quit out of the program. So I think that should be the next little piece we put in. Let's put in that next little piece for it, and we're going to say, let's put it way down here at the bottom after it does these ifs and checks and stuff. Let me move my screen up here a bit. Make sure I'm still on the video part of it. So I'm going to print here, and we'll say something like, I don't know, let's put a new line so it pops down a line and say, do you want to calculate again? And say yes or no. Y/n. So this would be a great question for it to ask next. I really should probably put all of this inside of an input, and then I could have it maybe do these things again. Let me actually maybe do that. Let's say, what should it be? Continue, calc, play. Yes or no? We'll have it be again. We'll just say again. So here we have one where I'm calling again, and we'll say, do you want to do it again? And then I can have it print this out. Print again, I guess. Let's run that, just make sure I have it in the right place. I'm going to save it too while I do this run. We'll do some little more addition, 3 and 4, and do I want to do it again? I can say yes or no. Just printing out my yes. So here's the point where I need to figure out, how am I going to keep this going? If we think about it, my program has just run straight down the code, and now I'm all the way at the bottom. And I don't really have kind of anywhere to go right now. So I really wanted to kind of go back and up to the top and do this again, but there's no real way for this to kind of work the way it's set up. So this is where I'm going to use a big while loop. I'm going to make it so that there's a or I could make it so it's calling another function and it runs everything that we've done kind of previously in a function. But I think in this case, wow, there's like 3 different ways I could do this. And I had totally intended on doing it one way, but maybe that's not the best way to do it. It might be a simpler way to have a smaller loop to do all this stuff. Let me think about this for just a moment. Yes, I think there is a different way to do this. Maybe a more modular way to do this, which might make a whole lot more sense. All right, change of plan. Change of plan. This is actually not how I did the part of it in class the other day, but let's do this. I'm going to take all of this code that's up here before. I'm going to have it still do the welcome, and then after that, there's going to be some functions in there, and so I'm going to take these kids out, and I'm going to put it down here after these other functions, like that. And so let's. I'm just going to do this for a couple of these so we can see this is our divide one. That's our divide. This is our multiply, subtract. Oops. Our other one. All right, so I'm just trying to like clearly mark out what those ones are. And then down here is going to be the one where we have a new function. And we're going to say, let's call it calc. Does it need any input? I don't think it needs any input. Do. And then I'm going to highlight this whole block and hold my breath and say, hit tab, and it should tab all of those in. If I tab things by mistake, I should be able to hold down shift and tab it back, tab it forward, tab it, shift tab goes back, tab, 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 shift tab, shift tab, shift tab. Should be like a TikTok dance or something. So, but that's for a different video. But, so what do I have now? I have this thing where it says calc. This whole calc thing is in one big thing. So what can I do here? So what I can do is I can make a small while loop down here at the bottom and have it basically be true at the very, very beginning of this whole thing. So we want to be playing, or again, yeah, let's say playing, calcing, what are we going to call it? Using, octave, mathing, let's call it mathing. We're going to start off the mathing to be true. If you're actually mathing, my wife would hate that because she's a math teacher, but if we were mathing, we'll say, we could say while mathing, I like to use parentheses here, mathing, not necessary, but I like to use them because you need them in most other languages. While mathing, then we want to do calcing. So we're going to tell it to calc, meaning calculate stuff up here. Let's call that a better. Calculate. And we'll call this one calculate. You have to say it in that voice. If you're doing this at home, you have to say it in that voice. So there we go. So while mathing, calculate. And then inside of our while here, boop, 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 I can now say, if again equal n, then we can say mathing equals false. So let me explain what I just did there. All right, so what's going on here is down here, this is our kind of our main setup. If we start off, we run the program, mathing is true, we're going to be doing math stuff. Then inside the while loop, we kind of get stuck in there. While this is true, while mathing is true, we're going to continue to say, hey, calculate, and try to do what we saw up there at the beginning. And we can then also say, anytime after it's done doing the calculation that's in the calculate section, after it's done doing all this, our program's going to come back here and it's going to say, it's going to ask again. And so if again is yes, it should do, the if statement does nothing, it's going to go back, it's going to continue in the mathing still true. That means we're going to then do the calc again, and then it'll come down and ask that question again. This is all in theory because I haven't actually saved it or hit play yet, but let's see if I did it right. So I'll do that. One thing I'm going to do here, because I'm moving back up and down the screen, is that you see where I've got my adder here and my other ones? I'm just going to do this. I'm hitting the little triangle next to them. When you hit that little triangle next to them, what's cool is that it kind of folds it all together so it takes up less space. So you can see there's the whole multiply thing, but I'm just kind of tidying it all up. And I can even do the same thing with the calc one here. So if we kind of look at it from this size, we can see it's really just 1, 2, 3, 4, 5 little functions here with this while loop, which I can even fold down too. It kind of really simplifies what our flow looks like in this tool. All right, so I'm going to hit play. This time I'm going to do a little multiplication. I'm going to say, I don't know, 8 and maybe a 2. I get 16. It's asking me if I want to calculate again. And I say yes, and it doesn't really know what that even means because I didn't set up a condition for it. And we're back again. And I can add my number in this one. And do I want to do it again? I could say no. And then it's actually done. So maybe here, maybe we'll put in something else. Let's have it print something else out so we know there's some other feedback. Thanks for mathing with us. Please come again. So here we've got it, so it's kind of does it, and when we're done and we say no, then we get out. Now, this is another case where if the n is not capitalized, it's not going to work. So let's make sure we add that little bit to our input. So again, dot upper, and then open close because it's like runs like a function. We'll try one more time. This time we'll do a little more adding. We'll do 29 and 12, and there's our answer. So now if I say no lowercase, it says, thanks for mathing with us, please come again. So we could simplify a lot of this. We can make a lot of our things kind of work out fine. The only thing that we don't have here is any kind of error catching for those beginning ones that are up at the top. You say if I put in any other value other than ASMD, it will give me some sort of error, or it actually won't do any of the things below it. Let's try that. That actually will be a good test. When it asks me this question, I'm just going to say, hey, Bob. And then it'll still ask me for numbers, but I put it in, it's not actually going to calculate anything there. It's not going to do any of those 4 functions. And there's one last bit here I could do to kind of augment that and fix that. And that is to put in a different kind of while loop that checks for good, valid data there. I can make sure that they're putting in either an A, an S, an M, or a D. And to do that, this is something we actually did in class. I could, up inside of our calculate section, add a sort of a catch there, an input catch that'll look and check to see if it's valid data. So we could do this as a separate function, but I think in this case I'm just going to, I'm going to do it just here. I'm going to put a while loop inside of here, and I need there to be, let's see, guess I don't need a whole nother separate variable for this. When I did this with my class, I did a new variable called op_ok, just meaning like, is that value that they put in okay? Let's use that for this particular case, although it may not be a great use of it. I'm going to say while it's not okay, and notice I'm using the exclamation point, and we've talked about that in my classes before. Exclamation point here means that it is not whatever the value is in there. So that means if it is false, then it'll continue to run this loop. Here I'm going to say op_ok, colon. And then inside of here, we're going to have it do these things. We're going to say while the operation's not okay, let's ask for input, and let's, oops, that's a little too far. And that's not right. While the operation is not a good operation, continue to ask for input. So inside of here, I'm going to have it do one if statement, and it's going to be a big one, but it's going to check all the conditions I can possibly think of here. So I'm going to say if the operation dot upper equal, meaning comparing it. If you do one equal, you're signing it. Here, 2 equals means it's a question. If it is an A, and then we'll say, or if upper, should have made operation shorter. Upper, let me copy that because I'm a coder and I'm lazy. If it is an S, or if operation open clues equal M in quotes. There we go. I'm leaving spaces out here just so I can save a little bit of space. And then lastly, you do need a space between the or and the rest of this. Equal quotes D. And then a colon at the very end of this. So take a good look before, because all that is not going to fit on my screen. Here, can I move this all the ways over? Not so much. Okay. So what I've got here is if, oh, stop. There we go. If the guy from Trinket's ever watching, it would be great if we could get rid of that extra white space on the side on certain occasions. This space is, for long statements, is really kind of, or even on the other side. So you can we want to use the whole browser. It'd be really nice if you could use the whole width of the browser. So if it's either A or S or M or D, or even lowercase versions of those because we're uppercasing them, then that's good input. And we want to say that the the operation information coming in is equal to true. Ooh. True. Now it should go on to the next part. It should go on to the next while part of the loop. So there it is. Let's test it, ladies and gentlemen, and see if I did this right. First, let's do a big old save before I enter any crazy while loops. And look at that, I made a mistake. Bad token. Oh, does it not? It doesn't like the exclamation point? We'll say if not okay. Sorry, wrong language. There we go. So while it's not, while op is not true, which is the case here, it's going to continue to do this. So let's see. If I put in now Bob as my thing, it just keeps asking me the same thing and not like, hey, you need to put in the right thing. So I could give the user some feedback here. And once I put in a valid letter, then it says enter your first number. I can enter my numbers, and there I get my answer. If I hit Y here, it doesn't matter. It loops me back around to the next operation. So this is all good so far. This is all great. It's wunderbar. What I could do here, if instead of my if being just the way it is, I can say else. Like if somebody puts in bad input, we can tell them print bad input. Please enter an accepted character. Or please enter A, S, M, D, or D. And end quotes. And save. And stop. And run. All right. So now if I put in garbage, it says bad input. Please enter A, S, M, or D. Yeah, I like that. Here we'll put in a /n for a new line there too. And I click over here and say I want my operation to be Sally. It doesn't do it. Let's run that again. Sale, no. Sally, there we go. Bad input, please put in the right one. A, yay. 9 plus 3 is 12. Do I want to do it again? No, thank you. Thanks for mathing with us today, ladies and gentlemen. So this is it ended up being, what, 56 lines of code, but we actually added in a couple while loops, a couple other cool stuff in there that added into it. And you can see there's all kinds of other ways you could do. You could change this pretty slightly and make it be really work towards very specific functions maybe you want it to. You could make one of your functions maybe be like a Pythagoreanator kind of like function. You could have it just put in like A and B and have it do C squared for you and calculate, you know, different, and even break them down. You could have any kind of function you could express in these terms. You can make it specialized just for that and make your own version of your own calculator. It doesn't have to be one that simply as like addition, subtraction, multiplication, and division. You could make it do sales tax. You could make it figure out interest rates. You can make it compound your interest rates. You can figure out all these things. Maybe not always the most exciting thing possibly to do, but it's definitely one of those tasks that once you've done and you've kind of figured out, you can easily kind of apply it to lots of other things. And this is kind of the simplest version of it. So I hope you learned a little bit of something from it. Oh my gosh, 43 minutes of talking straight. Whew, man, I'm glad I brought like that plus an extra water bottle, which I didn't even drink. Thank you so much. If you found big errors in this or whatever, please make a comment down below. If you feel so compelled, like, subscribe, and all that other junk. And thank you very much for sticking it out this long. I can't believe there's only like one person that did it. But thank you so much. And bye. I don't want to do it. I have not done this in a while. Let's stop before quitting program.